Well, welcome to this new course on learning to program the Arduino. Now, this is an update of an older course that I did, and it's been rewritten because the Arduino IDE has changed now to version, I think it's 2.3.2 that it's on at the moment, but it looks slightly different to the old IDE, so I decided it was time to create a new set of videos. So today's video is going to be just doing the basics of getting started. Now, when it comes to the Arduino, there's often a little bit of confusion. There is Arduino, the board, and then there is the Arduino IDE, that is the software that is used to write the code to control these boards. Now, for these tutorials, the board that I will be using is the Arduino Uno. I've got two types. There's an original type here with the plug-in chip, and one of the newer sort of copy type ones that uses a soldered on chip. We've also got the Arduino Mega, which is the same as the Uno but obviously with a lot more pins. There's an Arduino Duo. This is a much faster version with a completely different type of chip, and here there are some ESP32s, an ESP8266. There's even an ESP32 with a camera here built in. Now, the code that we learn on this course on these boards will be applicable to all of these other boards. So no matter what type of board you're looking at for your project, the code concepts that we will be learning are applicable to all of them. Now, as I mentioned, there's often some confusion between the software and the boards. So the software that we're going to use is the Arduino IDE software. This is it. It's, what is it? The Integrated Development Environment. So this is the program that is used to write the code that we then upload into our Arduino. So let's get started. Now, if you look on the bottom left of the intro screen, you will see a link to the Digital Town website, and the link that you want is lessons.php, and the reason is that for each lesson, all the resources for the lesson will be on that page. So going over to that page, there are some information on getting started and the IDE. There is a tour of the latest version of the IDE. There's how to download and install the IDE. And if you're really new and you haven't even bought a kit, there's some information on what to look for when looking for a kit. So going down to today's lesson, obviously we're on getting started, and there are two links that we're going to use today. The one is for the IDE. I just click on that. It takes you to the page to download the latest version, and the latest version today is 2.3.2. Just pick whatever computer type you've got and download the appropriate version. The other item that I've got listed as a link is the CH340 driver. And this is a download. Just download the item. As you can see, I've already downloaded it once. I've got a copy of this actually on the Digital Town website, which is where this is downloading from. And we're going to install this driver. Now, not all boards require the CH340 driver. This is an original Uno style board, and you can recognize it usually by the plug-in chip. There are clones that have the plug-in chip as well. There are then this type of board where the main chip is soldered onto the board, and these tend to have this chip here, which is the CH340 chip, and this is just the chip that is used to communicate over USB with your computer. Now, the original Arduino has a different chip, and all the drivers are downloaded with the IDE, but if you have this type, you need to install the 340 driver. But I would advise you to install the 340 driver regardless of which board you have. And the reason for that is, as you progress, you're going to buy different types of boards, and a lot of boards use the 340 driver, so you may as well install it now so that it's ready at a later date. So once you've downloaded the zip file, it's just a case of double clicking on it, opening it up, and on Windows just go to Setup and run the setup. Click on Install, and that's it. Now going back to the camera, if I plug in the USB, there we go. We've got some lights. I can see that the Uno is alive and ready for work. Now the Uno may be alive and ready for work, but now we need to make sure that the IDE is connected correctly to the Uno. So if your IDE has just been downloaded, probably you won't have Arduino Uno here. This line will probably be blank. So you need to go to Tools, go down to Board. Now in my IDE, you'll notice I've got a lot of different types of boards. Your IDE, if it's new, will only have AVR boards, and then just work up the top of the list and you will see Arduino Uno. Click on that one, and that then will set the board type. It's very important to have the correct board type because each board has a different layout of pins, and the board type inside the Arduino IDE basically gives the IDE some information about when you upload the code, this is what the IDE needs to know about the board that it's being connected to. Now the next thing is, not only do we need to select the correct board, but we need to select the right COM port or communications port. This is the port, if you like, the USB port that your computer will connect to your Arduino over. So once again, go to Tools. Now the default is COM port 1. We do not use COM port 1. If you unplugged your Arduino, you will only see COM port 1. You'll notice I've got 1 and I've got 37. Now you may have all sorts of different numbers. I tend to have quite a lot of COM ports on my computer, so I've got COM port 37. Click on the COM port that is listed there that is not COM port 1. So if I click on 37, you'll see now in the bottom right hand corner we are now using an Arduino Uno on COM 37. Now to test that everything is connected correctly, although there's nothing in this sketch, it's not doing anything. If you click on this arrow here, this is the upload button, and then I want you to watch these LEDs here as I click on upload. So here we go. You notice you just see those LEDs flashing. That is the computer passing the information to the Arduino, and as you can see, we've uploaded a sketch. It's 444 bytes long. It's used up 1% of the storage space on the Uno, and it's used 9 bytes of global variables. Don't panic about those at the moment, but it just shows that the code has uploaded to your Uno. Now, the goal of this course is to teach you not just how to build some projects that I've built, but to be able to design and build your own projects. And as such, this is going to be a course about how to use the Arduino language rather than just building a project. Now, we will build some stuff, but the reason I'm going to teach you the language is because it is the area that most people's projects fail on. So if we just start by looking at this empty sketch, we have what is called a function. It is called setup, and then we have a second function that is called loop. So let's have a look at what is going on here. Now I've created this diagram of how the Arduino works. It's a little bit basic, but I hope it does the job. So we have the setup, and the setup is a function that we put code in that is used for preparing the system. So that might be telling a particular pin, whether it's what's called an input or an output. An input is when something is coming from the outside into our board, and an output is a signal that is sent out to control something else, and you'll see those within the main loop. But when we start the system, we have to tell our board whether each pin is an input or an output. Sometimes there's other things such as libraries that need to be started, but these are items that are done once. It's a bit like jumping in your car and starting the engine. The engine is now running. Now we're going into the loop, and we're going to start to deal with the different situations that we might come across as we're driving. So as we start to, if you like, drive our Uno, there are things that will give us information. Just like driving a car, you might see a sign, you might see a bend, someone steps out into the road. You see these things. These are, if you like, inputs. So they are saying something has happened. The output is the reaction to the input. So someone steps out into the road. Our output, hopefully, is we hit the brakes. Our input, we see a bend. The output is we turn the steering. Now, with our Arduino, our inputs, they can be buttons, they can be sensors, it can be time. That can be the time as in the time of day, or it can be a time in milliseconds since the board was switched on. We could have keypads, infrared remote controls, rotary encoders, various types of communication. It could be something coming in from another Uno. There's all sorts of methods, if you like, different input types that our board can receive. And at the same time, there are outputs. Now, our outputs could be very simple. They could be an LED. We could be driving a servo, a motor, stepper motors, LCD displays, sound, relays, outbound communication. So we have our inputs and our outputs. But the bit that most people get stuck on is not the inputs or the outputs. It's the logic code that is in the middle, if you like, the bit that says, well, if a button's been pressed, I now want this board to do something with an LED, a servo, a motor, or whatever. So going back to our IDE, we have the setup. These are the items that will run once. Then we have the loop. So the code will be read from the top of the setup. It will work its way through our lines of code to the bottom of the setup. Once it's finished all of that, it will jump to the loop and it will read our lines of code. When it gets to the last line of code, though, it will jump straight back to the top and it will go through that loop again. Now, one of the things that is hard to get your head around with an Arduino is just how fast it is. It runs at 16 megahertz. Now, that means that it processes 16 million instructions per second. Okay, just think about that, 16 million instructions per second. So the way it works is, even if we wrote no code, so if we go back to our sketch that we've got with no code here, it means that this loop is running on an Uno approximately 3.5 to 4 million times per second. Okay, get your head around that. 3.5 to 4 million times per second. Very often I see questions from people saying, well, is the Uno capable of controlling, this item or that item? Well, actually, most of the time when we are writing our code, the Uno is actually sat there bored, waiting for something to happen. But depending how we write the logic code here has a huge effect on how our program interacts and works. The goal of this, if you're sat at a computer, right now, looking at my computer, I have the mouse. So when I move the mouse, there is something within the computer that is getting an input of the XY position of the mouse and any buttons that I press. There is then some logic that is running on my computer that says, do something with the display, move the mouse pointer on the monitor. So if you like, the mouse itself just sends some information to the loop, and my logic code then controls the display. The same with my keyboard. If I press a button on the keyboard, the logic code then works out which key has been pressed and outputs it to the display. That's how a computer works. Now, the important thing is that if we write the code correctly, then we will get a smooth input and a smooth output. If our logic code is written badly, it would be a bit like I press a button on my keyboard and I have to wait 2 minutes before I see the screen update. And if you don't learn the code, the logic behind your code in the right way, and a classic one, I'm going to start with it now, is you will see a lot of code with something called delay. Now, going back to our setup, I'm just going to type in this little bit of code, and delay looks like this. So that would cause a delay of 1 second. Now, people use delay to control their code, but it is a very, very bad idea. We go back to our diagram. If you use delay in your code, this loop literally stops. So that means it might cause a gap in your code. It might cause your LED to pause between flashing on and off, but during that delay, it cannot read any other buttons or sensors, and it cannot output any other information. So if you wonder why on this course you will not see delay used, that is the reason. Most beginners have huge problems with their code because they use delay. Going back to our sketch, let's get started and actually write some code. Now, the first thing I'm going to teach you is not actually to write code, but to write comments. Now, there are two types of comment. There's this type of comment that has the, if you like, the 2 / marks. You'll find these on the numeric keypad, just above the numbers. There is another type of comment, and that uses a / with a star. Now, if you look on your numeric keypad, you'll see they're next to each other. That starts the comment, and to end it, you do the opposite. Now, what I tend to do in my sketches is we'll call this sketch 1, and I'm going to put a date on it. What is the date today? 21st of the 5th, 2024. Now, the reason for doing this, putting information in this sort of block comment, it's very useful as your sketches progress. Today, we're not doing much, but if you start to use lots of pins and different things, it's good to write in here just what you are trying to do. Now, I'm now going to save the sketch as something. And where are we going to go? We're going to go in lessons, and we will go sketch 1. So we've got sketch 1 saved. And so we now understand the block comment. A line comment, I can put another line in here, another comment. Basically, anything after these 2 symbols is a comment. Now, you can write as many comments as you want. Do not worry about the number of lines that are either single line comments or block comments. You can write a huge amount of information. It doesn't matter because it doesn't get uploaded to your Arduino. It's not going to take up any memory, but it's going to be there for your own reference. And commenting code is a very important part of programming, because when you come back to a bit of code 6 months later, if there are no comments, you won't know what you are doing. So let's get rid of that delay. We really don't want to see delay in our code. And what we're going to do, we're going to start off by just writing a little sketch that says hello. So we're going to start by sending out an output via the serial port. Now you remember when we set up our board, we're on COM port 37, and that is connected to your computer. Now, if you click over here on the right on the serial monitor, you see it brings up this little area down below. We can send information from our sketch to our computer and it will appear in this area. So all I'm going to do is send the text "Hello World" to the serial monitor. Now to do this, we have to start the serial monitor and we have to start it at a speed. We're going to use 9600, and then we're going to send some information. Hello World. There we go. So that is the sketch. Now my Uno is already plugged in, so if I send this to my Uno, compiling the sketch, and in my output I see hello world. Now you'll notice I've got the time on. If you click on this icon here, you can see that the time gets removed. So if yours didn't have that time there, don't panic. There's not a problem. It's just this clock symbol here. Now, I haven't really explained what is going on here, but the important thing that I wanted you to see is that Hello World got printed out once because the setup started, it read this line. Now, this is starting the communication system off. One thing that is important, you see this value here, 9600, that has got to be the same value as you see down here. Now, if I change the baud rate, let's set it at 115200, let's clear the output, and I'm going to upload the code again. And you see I've got a weird line of boxes. That is because the baud rate is set to the wrong value. So it's very important that the baud rate is the same when you begin as the serial port is expecting. It's to do with the speed that data is being sent. We're not going to go into that in this lesson, but it's just something that you need to note. If you start seeing funny characters, the chances are your baud rate is set incorrectly. So let's set it back. Now, if you want to clear any data that is in the serial monitor, just click on this symbol over on the far right, and that takes everything away. So going back to our sketch, we've started the serial monitor at the right speed. We've sent out some information, hello world. Now what I'm going to do is I'm going to put another line in here, and we are just going to put in the sketch name. Now I tend to do this in all of my sketches because it means that if I pick up an Arduino and plug it in, I instantly can find out what sketch was on the board so I don't overwrite something that is important. Now what we're going to do next is I'm going to move this line and I'm going to put it in the loop. Now we will upload and we will see what happens. Now you'll notice at the beginning I've got sketch 1 and then endless hello worlds. In fact, if I turn the clock on and get it scrolling, you'll see that it is constantly writing hello world time and time again. And this is the difference between the setup and the loop. In the setup, it goes through once. So we start at the top, we work down, we've sent our line of information, we got to the bottom of the setup, and then we jump to the loop. In the loop, it wrote our line of text once, got to the bottom of the loop, jumped back to the top, and it goes through the loop again, over and over, writing hello world to the serial monitor. Now, feel free to write this sort of sketch yourself. For information on these functions, we're going to go into them more in the next lesson, but always remember there is a reference that is built in. Click on the language reference, and the serial communication, he says, is down here. And there is information about the different functions. We have used begin, and we have used serial print line, isn't it? Where are we? There we go, print line. Print line puts a carriage return at the end. Print does not put the carriage return at the end. If you click on these functions, there are always examples of how to use them. Now, at this point, I don't want you to panic too much about understanding this, because as I've said, we will look at it at the next lesson. What I want you to understand, though, from today, how to comment your code, because that's going to be important. The reason being able to serial print is important is that obviously our Uno doesn't have a monitor like a computer would have, so we need some way of getting information out, especially when our code gets a little bit more complex. It's very useful to be able to write things to the serial monitor to see if there is an issue somewhere in our code. But the other thing that I just want you to understand today is the difference between the setup and the loop. The setup, the code runs once. The loop runs continually. Now I'm going to end the lesson here because I'm trying to keep these lessons into bite-sized chunks, but in the next lesson we'll start to look more into how we use the serial monitor and how we print out different types of information. So hope that's been helpful to you, and I'll see you in the next video. Bye for now.